7.4 Transformations of exponential and logarithmic functions. So we've already done transformations several times this year, and we are now looking at, just like we did for the last section, exponential and logarithmic functions, just looking at the transformations now. If we have, this is basically the same thing that we've looked at every single time. The examples over here are just a little bit different. Everything else is the same. We start out with f of x plus k is a translation up because of the plus k on the end. So if our x is in the exponent, the plus 5, for example, is on the end. Our x is here with a log, the plus 5 is on the end. Same thing with the translation down. It's a minus, so it's down. So it's minus 5 here on the end or minus 5 here on the end. Then, if you have a translation to the left, you're going to have a plus h on the inside. So where the exponent is, or where the variable is, I should say, you have x plus 5 here. If it's log, then you have x plus 5 inside the parentheses. Your minus h on the inside is a translation to the right. So I have x minus 5 here with the x in the exponent, or log of x minus 5 in the parentheses. The negative out front is a reflection across the x-axis. So my negative is out front here, or my negative is in front of the log. That's for the reflection on the x-axis. If you have a negative on the inside, it's a reflection across the y-axis. So your negative is in the exponent with the x here, or your negative is with the x on the log. And that's inside the parentheses. Now, if you have a vertical stretch or shrink, your a is out front. It is a vertical stretch if a is bigger than 1. So if you have a 2, for example, out front, or if you have a 2 out front right here, it is a vertical shrink if a is between 0 and 1. For example, 1/2 out front, or 1/2 out front here. If you have an a on the inside, it is a horizontal stretch or shrink. So if we're looking at a horizontal stretch, a is between 0 and 1. For example, in the inside with the variable, we have a 1/2 inside, or we have a 1/2 in the inside here. That is by a factor of 1 over a. Here, with the vertical, it was a factor of a. Remember, down here with horizontal, we flip it. So now we have a horizontal shrink of 1 over a if a is bigger than 1. So this 2 right here, or this 2 right here that's on the inside. So now let's look at example 1. It says describe the transformation of f of x equals 1/2 to the x power, represented by g of x equals 1/2 to the x power minus 4. If you look carefully, the only difference that you have between the original and the new function is that minus 4 on the end. Then, of course, it says graph the function after you're finished. So this minus 4 is a translation down 4 units. And then to graph, guys, all you're doing is putting this right here in your calculator, and then you're putting this right here in your calculator. So what you will be seeing, and this is the exact replica of what your calculator screen would look like, your f of x is this blue line, and your g of x is the red line. Then you would transfer that to your paper. So remember, you might have to press Control T for the table so that you can plot those points. Okay? Other than that, everything else is the exact same as it has been every other time we've done these transformations. It's just a different parent function. So describe the transformation of f of x equals e to the x, represented by g of x equals e to the x plus 3, and then a plus 2 on the end. So if we're looking at that plus 3 right there, then we have a transformation with that. We also have another transformation with the plus 2. So the plus 3 is a translation 3 units to the left. The plus 2 is a translation 2 units up. And then we graph. So there are our two functions. The original is the black line. The new function is the purple line. And from there, you're just going to graph on your paper. Again, Control T is going to give you the table. Example 3, moving right along. Describe the transformation of f represented by g, then graph each function. So if I'm looking here, I start out with f of x equals 3 to the x. I go to g of x equals 3 to the 3x minus 5. There are again two transformations. I have this 3 that's in front of the x in the exponent, and I have this minus 5. It is still in the exponent, so we can act as if there are parentheses around that exponent. It is in the grouping. So, if I'm looking at that, just looking at the 3, since it is inside, it is a horizontal movement. Horizontally, if the 3 is bigger than 1, I have a horizontal shrink, and it is by a factor of 1/3. That comes from that 3 that's right there. Then the minus 5 tells me that I have a translation to the right 5 units. And again, Control T for your graph. The green is your f of x function. The orange is your g of x function. Okay. B. I'm starting with f of x equals e to the negative x. My g of x is negative 1/8 e to the negative x. Look at your differences. The only differences I have in these two functions are going to be the negative right here and the 1/8 right there. So the negative is in front. It is not in any parentheses, so that's going to tell me a reflection across the x-axis. The 1/8 is also out front, so it's a vertical. It's between 0 and 1, so it is a vertical shrink by a factor of 1/8. So right here, your negative goes to your reflection. Your 1/8 tells us about the vertical shrink. And here are your graphs. Right here is my f of x, and the blue is the g of x. Example 4. Describe the transformation of f represented by g, then graph each function. Same thing, except now we have a log. So log of x, and then it changes to log of negative 1/2 x. Again, two things. Negative out front, or sorry, negative inside, and 1/2 inside. The negative inside is a reflection across the y-axis. The 1/2 inside. Inside tells us a horizontal movement. Since it's multiplied, it's either a stretch or shrink. It is 1/2, which is between 0 and 1, so it is a horizontal stretch by a factor of 2. Don't forget, you have got to flip this. You've got to take that 1/2 and flip it to be a factor of 2. The negative, again, told us our reflection across the y-axis. Put them in your calculator. Here's your graph. Anytime there is not a base, it is automatically base 10. Anytime whatsoever there is not a base on a log, it is automatically base 10. So this red is your f of x, this black is g of x. Part B, log base 1/2 of x. And then I have 2 log base 1/2 of x plus 4. Two things. I've got a 2 out front. I've got a plus 4 on the inside. The 2 out front tells me a vertical stretch by a factor of 2. The plus 4 is on the inside. So it tells me a translation 4 units left. Translation 4 units left. And again, just graph. I'm going kind of quickly through the graphs because that is something you should already know how to do. We've graphed 100 times. You're just plugging it into your calculator. Example 5. We have a couple more after this one. Actually, just one after this one. Example 5. Let the graph of G be a reflection in the x-axis followed by a translation 4 units right of the graph of f of x equals 2 to the x. Write a rule for G. When it says to write a rule, we are simply writing a new equation. The first thing you need to do is look at what you're trying to get. What are your changes? Let the graph of G be a reflection in the x-axis. That's the first thing. Followed by a translation 4 units to the right. So I am starting off with f of x equals 2 to the x power. And guys, this right here is something that you all struggle with. Make sure you pay attention. Please make sure you look at the steps and follow the steps. Use your notes. So right here, if I have f of x equals 2 to the x, since it says followed by, I have 2 steps. I'm starting with h of x. This reflection is my h of x. It's on the x-axis, so that right there tells me a negative out front of my f of x. All I'm going to do now, since I have a negative out front, is multiply that negative times my 2 to the x power. So I just have a negative out front of that. H of x equals negative 2 to the x. Second step, you have g of x equals, well, this right here is your g of x movement, the translation 4 units right. So I'm going to take h of x, and if I'm going 4 units right, that is on the inside, and I'm subtracting 4. So wherever my x is, I am changing that x to become x minus 4. So I have negative 2. The x is in the exponent, so I have x minus 4 now in the exponent. And nothing else changes. I cannot simplify that anymore at all. There's my final answer. G of x equals negative 2 to the x minus 4 power. Okay, we're going to look at one more of these. And this is example 6. Let the graph of G be a translation 2 units up. So that's going to be my first thing, h of x, followed by a vertical stretch by a factor of 2. That's my second thing. That'll be where I do the g of x. Of the graph of f of x equals log base 1/3 of x. So start out with your f of x equals log base 1/3 of x. Write a rule for g. So here we go. H of x equals translation 2 units up. That 2 units up is just a plus 2 on the outside. So I'm just retaking that f of x and rewriting the whole thing and tagging a plus 2 on the end. Log base 1/3 of x, and then a plus 2 right there on the end. That part's done. Now I can go to g of x equals, it says vertical stretch by a factor of 2. Vertical is on the outside. It's a vertical stretch, so it's in front, factor of 2, times my h of x. That just means I am multiplying every single solitary piece by 2. So 2 parentheses, log base 1/3 of x plus 2. That's all inside. So now I have to distribute. So I have g of x equals 2 times log base 1/3 of x plus, and 2 times 2 is 4. Now, don't get confused because that is not 21. That is an L for the log. So just so there's no confusion, I made that a a cursive L right there. So that's 2 times the log of 1/3 x, log base 1/3 of x, I apologize, plus 4. That right there is your answer. Okay?